where I assign my reference node is completely arbitrary. I'm going to say up here is going to be my reference node, and that will be my 0 volts. Now if I define my independent and dependent nodes, so I killed my sources just as before. I don't need to write down my resistance values. This guy here is now my 0 volts. This is still all one big node, and this is a node. So let me call this, I don't know, VB, and then I can pick any one of these locations as being my other independent voltage. I think I'll pick this bottom section of this here as my other node VA. So defining my nodes on my original drawings, here's VB, this is going to be VA. Now, because of the voltage sources, I have a dependent source here and here. The voltage here is 6 volts above VA. This is the positive terminal, this is the negative terminal, so this voltage is going to be VA plus 6 volts. The voltage over here above the 12 volt source is going to be 12 volts plus minus above VA, so this is going to be VA plus 12 volts. Now, because of these voltage sources, I can create one big supernode around all of this and sum the currents leaving that node. So I'll have currents going through the 3 ohm resistor, currents going through this other 3 ohm resistor, and currents going through this 6 ohm resistor. So KCL at supernode A, the current through this 3 ohm resistor is VA plus 12 volts minus VB, so plus minus over 3 ohms. The current through this 3 ohm resistor is going to be VA minus 0 volts over 3 ohms, plus the current through this 6 ohm resistor is going to be this voltage minus this voltage. If the current's going out of node A, this has to be my positive voltage terminal. So VA plus 6 minus 0 volts over 6 ohms is equal to 0. Now KCL at B, I have 2 amps leaving that node due to this source. So if I assume positive currents are leaving, that becomes a positive 2 amp contribution. The current through the 1 ohm resistor is going to be VB minus VR, which is 0 volts over 1 ohm, plus the current through this 3 ohm resistor, now defined positive in this direction, is VB minus VA plus 12 volts over 3 ohms. That's all the currents I have to deal with. Those sum to 0. Now, an equation for the voltage V. V is the difference between VR, which is 0 volts, and VA, with the positive terminal being at VR. So V is equal to VR, or 0 volts, minus VA, which is just equal to the negative of VA. I now have 3 equations and 3 unknowns. I can solve these for the voltage V.